Have you ever wondered how modern car engines run so smoothly and efficiently? The secret lies in a network of advanced sensors that monitor and optimize engine performance in real time. In this video, we will explore 10 essential sensors in a car engine, how they work, and why they are crucial for your vehicle's health. But before we continue, hit the subscribe button and turn on the notification bell to be the first to see our video. Let's dive right in. Number 1. Mass Airflow MAF Sensor. This sensor measures the volume and density of air entering the engine, allowing the engine control unit, ECU, to adjust the fuel injection accordingly for an optimal air-fuel mixture. The MAF sensor works by using a heated wire or film that cools down as air passes over it. The ECU measures how much electrical current is needed to maintain the temperature, which helps determine airflow. A faulty MAF sensor can lead to poor acceleration, rough idling, black smoke from the exhaust, or increased fuel consumption, often triggering a check engine light. Number 2. Manifold Absolute Pressure MAP Sensor. The MAP sensor detects the air pressure within the intake manifold, providing real-time data to the ECU to calculate the correct amount of fuel and adjust ignition timing. Unlike the MAF sensor, which directly measures airflow, the MAP sensor determines how much air is entering based on pressure differences. This sensor is especially critical in turbocharged and naturally aspirated engines, as it helps compensate for altitude changes and engine load variations. A malfunctioning MAP sensor may cause engine hesitation, difficulty starting, or even cause the engine to stall when accelerating. Number 3. Oxygen O2 Sensor. Found in the exhaust system, the O2 sensor monitors the level of unburned oxygen in the exhaust gases. The ECU uses this data to adjust the air-fuel ratio dynamically, optimizing fuel efficiency and reducing harmful emissions. Modern vehicles often have multiple O2 sensors, one before and one after the catalytic converter, to ensure emissions are within legal limits. A failing O2 sensor can cause the engine to run too rich, too much fuel, or too lean, too much air, leading to rough idling, increased emissions, poor fuel economy, and even damage to the catalytic converter over time. Number 4. Throttle Position Sensor, TPS. The TPS measures the angle of the throttle plate, providing feedback to the ECU about how much the driver is pressing the accelerator pedal. This information allows the ECU to control fuel injection, ignition timing, and transmission shifts in automatic vehicles. It works using a potentiometer or a Hall effect sensor to detect movement. A failing TPS can lead to symptoms like unresponsive throttle, engine stalling, sudden surges in power, or difficulty shifting gears in automatic transmissions. If left unchecked, it can significantly impact drivability. Number 5. Crankshaft Position Sensor. This sensor keeps track of the crankshaft's rotation speed and position, which is essential for engine timing and synchronization. The ECU uses this data to determine when to ignite the air-fuel mixture and when to inject fuel into the cylinders. It is commonly located near the crankshaft pulley or flywheel and operates using a magnetic or Hall effect sensor. A malfunctioning crankshaft sensor can result in hard starting, engine misfires, rough idling, or even a no-start condition, as the ECU may not be able to determine proper ignition timing. Number 6. Camshaft Position Sensor. This sensor monitors the camshaft's speed and position, which helps regulate the opening and closing of intake and exhaust valves. The ECU relies on this data to ensure the right timing of valve movements in relation to piston strokes, optimizing fuel injection and ignition timing. This sensor is particularly crucial in variable valve timing, VVT engines. A failing camshaft position sensor can cause difficulty starting, poor acceleration, engine hesitation, or even trigger the check engine light. In some cases, the engine may enter limp mode to prevent further damage. Number 7. Coolant Temperature Sensor, ECT. This sensor measures the temperature of the engine's coolant and sends this information to the ECU. The ECU then adjusts fuel injection, ignition timing, and the operation of the cooling fan to prevent overheating. If the engine is too cold, the ECU may increase fuel delivery to aid in warming up the engine. A faulty ECT sensor can cause inaccurate temperature readings, poor fuel efficiency, engine overheating, or a non-functional cooling fan, which can lead to severe engine damage if not addressed. Number 8. NOx Sensor. The knock sensor detects abnormal combustion or knocking sounds inside the engine caused by premature detonation of the air-fuel mixture. It transmits signals to the ECU, which adjusts ignition timing to prevent further knocking and potential engine damage. Knocking is harmful as it can create excessive heat and pressure, leading to piston and cylinder head damage over time. If the knock sensor fails, the engine may experience power loss, increased fuel consumption, or even severe engine damage due to prolonged knocking. Some vehicles may also enter safe mode, limiting performance until the issue is resolved. Number 9. Fuel Pressure Sensor. This sensor monitors the pressure of the fuel inside the fuel rail and ensures the proper fuel supply to the injectors. The ECU uses this information to regulate the fuel pump and maintain consistent fuel pressure for efficient combustion. If the fuel pressure is too low, the engine may experience power loss, misfires, or hard starting due to fuel starvation. If the pressure is too high, excessive fuel can flood the engine, reducing efficiency and increasing emissions. A faulty fuel pressure sensor can lead to poor acceleration, engine stalling, or a drop in overall fuel economy. Number 10. Oil Pressure Sensor. This sensor tracks the oil pressure in the engine, ensuring proper lubrication of engine components. If the oil pressure drops too low, the sensor triggers a warning light on the dashboard to alert the driver. Proper oil pressure is essential to reduce friction and prevent excessive wear on internal engine parts. A failing oil pressure sensor can cause false warnings or fail to detect low oil pressure, which could result in engine overheating, increased friction, and eventual engine failure. Regularly checking the oil level and ensuring the sensor is functioning properly can help avoid costly engine repairs.